My name is Catherine, and I'm going to be taking you through machine learning operations deployment, which is MLOps. Yeah. For our introduction, we are going to say deploying our machine learning models for production after training them. This is like the last step that we have. And first of all, what we do, we create a virtual environment. After creating the virtual environment, we decide to create a Flask. We decided to use a Flask platform, and in that Flask platform, we placed Fast API as well. Now it's used for optimizing our backend for efficiency. Then for front end, we used HTML, and lastly, we used Render for deployment. Uh, when we are starting with this, we look at our data set. We actually, for us, we are going to be uploading our images, but for our models, this is the training process that it had. They have data processing. The zip files, the images were extracted, and after extracting, they were resized and converted into RBG. The model we are deploying used ResNet. Then for training, this ResNet model decided to train a student who uses contrastive learning, the convolutional neural networks. Then from there, we evaluated our student model and the teacher model using F1 score, precision, and accuracy. And then later, we tested that model to check if it works. Then, yes, we selected the model that we were going to deploy. So when it comes to model deployment, we built and saved it using TensorFlow, and we are using Flask for the UI for the model, and then we shall use the Fast API to display images on the UI. It will be deployed on Render.
Hi, my name is Luganzi Matthias, and I'm going to be explaining a bit of deployment. As my colleague has mentioned earlier, the process we went through the deployment to deploy the model. For example, we created a virtual environment. Then we were able to write the different files using Flask and Fast API. Our files were later pushed to our GitHub, and then connected to the Render account where we are hosting our model from. Okay, so to start with the code, we actually have a templates folder which is containing the HTML file that is displaying the UI on our screen. So this is our template folder, our HTML file. So basically here, this is only CSS. I think I'll start from here. Here we are required to upload the image. So after uploading the image, it's supposed to append the file to the input file. Then it's supposed to give you a notification whether the file is saved or not. And then if it does so, if it's saved, it will be able to push it for processing. If it's not, then to be able to give you feedback or give you a 405 error, which is no file existing. Then unable to process, that means the image was not loaded successfully. Then we have the app.py, which is a file where we did the computations and also loading the model. So in this case, we start our project with importing the necessary, making the necessary inputs. For example, we imported Flask. We also imported PyTorch, NumPy, and also Pillow for converting the images. And then also we imported OS. The reason why we use PyTorch is because it's lightweight than TensorFlow, and also it's more compatible with Python than Tensor is. In our code, we started with loading the model. We loaded our model using load by touch model. Since we're using ResNet model, the reason why we use the ResNet model is because it was executing very fast. and then it was producing good output. Other models were equally working well, but the execution rate was low, and we never wanted it to take long while processing due to low computational power at render that is provided for free. After the model is loaded, it's supposed to look out for the location of the model, which is just located within the user account, which is our main folder where all files are. Then it receives the images. The images are processed here, where you can see we're doing normalization and resizing of the images. They can be executed faster since our images are of high contrast. And then having the function that is actually executing the model, making the prediction. So here, the execution starts with receiving the file from the HTML, or like how you're going to see when you're uploading the file. Then it resizes it. Then it's able to convert the image from the NumPy array to pillow images, or what we can say as a JPEG, so that it can be processed by the model since we trained it using JPEG, not NumPy arrays. Then the model is able to transform the image features and be able to predict whether the tire is good or defective. Okay, I think we can go to the demo and see how our code works. So this is how our app GUI looks like. So here, this is where we upload our image from. You come here and then you choose an image and then upload it here and then click analyze and then to start processing the image. Since the process takes long, our project is a bit huge and takes some good time to process. Let me load the image that I can be able to go and explain something on the render dashboard and also GitHub as it processing. So when I click choose image, I'm going to go to the good data set. I'm going to choose an image. For example, I'm selecting this and I'll open the image. So the file good 59 is loaded here. Then when I click analyze, it will start showing processing image. So let it be processing as I'm explaining something here. This is our render account where we are running our project from. As you can see, this is our render URL, the project here. And then our project is called ResNet, which is running here. So as you can see, the server is live and it's running. Then there is also our GitHub, where I wanted to show you something. So this is our GitHub, where we uploaded the files that are uploaded to render when you make a deployment. Our file, the repo is called TNN, and these are our files here. The templates file that is containing our templates, where the template for this UI is. And then we also have the apps.py, which is the main file that is running the application. And then we have the requirements.txt, where our requirements are installed. And then we also have the tire defect model.pth. And this is the model that we are running. And then we are expected to receive our results from this model. So if I go back here, as I said earlier, the model takes time processing because it's using a combination of ResNet and CNN for feature extraction. So earlier today, I made some changes to the repo and then I uploaded them so I can be able to modify the code. So when you look at our server, as I said, it's live and it's been running for the past, I think, about 30 minutes. Yeah, I think this is all about the repo. And then this is the demo for the code. As you can see, it's still running, but very soon you shall be getting our results. For the case of time, I'm not going to run another demo because This will take some good time while processing, but that's about our MLOps. Thank you.